Yeah, good day, all of you. And this is Srinivas Kilambi. I'm the founder and CEO of Sriya AI, a deep tech AI company in Atlanta. I have two of my colleagues, Stephen Howell, who is the co-founder and the chief operations officer, and Dr. Bala Punjab, who is our venture partner and an expert in industrial operations, especially in pulp and paper industry. So my background is I'm a PhD in chemical engineering. I'm also a CFA, and basically today we're going to talk about the intersection between the beauty of this new AI technologies in the world, including ours, and the industrial applications which interest most of you and others who have not joined, who may join in this world. So how they connect, how this technology can really be a big enabler. That's the whole point of this today's session. I hope you find this interesting, informative. And any questions, please put in the chat, and we'll be glad to take them at the end, or we can reply individually as we see as we decide. But again, thanks for joining, and we go. So what is Sriya AI? As I told you, it is a startup in Atlanta. It's a company which the technology is and have been under development for 5 years. So I have been the inventor of this technology, and let me talk to the evolution of AI as I see it. So, or let's start the intelligence. So it all began with SAPs and Power BIs, and in the 80s to 2000. In 2000 to 15, data analytics became the buzzword, and people talk about data analytics, data science. I think data science is different from data analytics. Data analytics, I call it more of an art. It's more of visualization, creating nice pictures, nice trends, but ultimately, in my humble opinion, you don't get much value of it. Yes, you see something, but it's great to see. A picture says better than 1,000 words, but that's what it is. From 2015 onwards, people began with what the true AI ML and machine learning, and it started with what's called predictive analytics, which C3 AI, a public company, is probably one of the biggest stories in this category, and it does what's called predictions in business applications of what will be the outcomes going forward. So it tries to learn from the past and then go forward. Then came in 22, we all know Gen AI, ChatGPT, OpenAI. The big difference between Gen AI and traditional AI ML is that traditional AI ML focuses on predictions. Gen AI focuses on content creation. It's more NLP. It tries to create content on demand, and from the content, you're supposed to infer what you want or get what you want, hopefully. That's the whole idea behind it. And we know the success story of OpenAI and how many companies have now come up in the last 1 year. I believe over 10,000 who are trying to do something with large language models as we speak. That's what we speak right now. So that's okay. So then comes Sriya. So Sriya AI began, we were officially incorporated last year, and we call ourselves AI Squared. Now, you've heard of AI. So I'll talk a bit about what AI Squared is. Okay? So AI Squared is a technology or a term which we have brought in. It is AI teaching AI, or AI learning from AI to improve business outcomes. So it's a big difference between AI Squared and AI. So in AI, the focus is to give predictions with a decent accuracy. In AI Square, it is to go beyond and actually give improvements. So let me talk about why we brought in AI Square, first of all. Okay, so again, I'll talk about the two most important categories of AI ML, namely the standard AI. Hold on a second. Yeah, the standard AI ML. The standard AI ML is fantastic when it works, right? But a majority of the times it doesn't. Because the features are too many, or the data is too small or too big. The features are too interwoven, interdependent. So what happens is that the models break down. There's a big distinction between models and algorithms. The algorithms like XGBoost, Random Forest, they work. Nothing is wrong with them. The problem lies in the model creation and how the model represents the data and the outcome. If the model doesn't represent the data and the outcome, then it fails. One more reason it fails is because there's too many features. A human brain has a tough time understanding 3 dimensions. Forget about 30. So if you have 30, 40, 50 features, even if the model has come back with a great answer, we're not able to find it. That's what happens. Oh, where is it? I can't find it. There's just too many trends here. So again, people back to square one. Then comes Gen AI. Gen AI is not a substitute for predictive AI. It's very different. So Gen AI is basically using large language models, NLP, understanding whatever is available in the World Wide Web, all over the world, and try to come up with the best answer to your question. Okay? And it is supposed to give you the best answer based on everything available. And it's supposed to create content on demand. So you could ask, like, it's supposed to write a code, edit a code, write a business plan, marketing plan. Fantastic. It works beautifully in those things. However, it has got a couple of, I would say, shortcomings. One is it doesn't work on much of numerical data. You put number 10, what can LLM say about 10? 10 is 10. 10 is not 9, 10 is not 11. There is no room for any discussion there. So if you put 10, it comes back as 10. You put 20, it comes back as 20. So that's one big, I think, limitation is that it doesn't work much. It's a natural language processing technology. It's not for alphanumerical, and most business applications are largely alphanumerical. So if you look at supply chain, number of orders in back order, if you look at optimization of a productivity, what is the yield, energy efficiency, all these are numbers. So basically, numerical data has a very little use in LLMs. So what did we do is we actually tried to bridge the two, and we created what's called AI Square. It's a result of over 5 years of work, and it goes on 2 layers of AI. The first layer of AI is creating what's called an index or a score, and everything starts with a score, because there is a saying, what can't be scored or what can't be measured can't be improved. That's standard, right? So I talked about in standard AI, you have 30 dimensions. We can't understand 3, forget 30. So what we have done is eliminate all those 30 into one super feature, something like a credit score. How easy it is to understand a credit score. So anything over 780, 800, fantastic. Close your eyes, give the person a loan. Anything below 550, forget. Don't even bother. It will default. Between 550 and 750 is a work in progress. It's very clear. Rather than how many loans did he take or she took, how much did the default, what is the payment balances, all those features go towards the credit score. But the one number makes more sense. S&P 500 index, one number makes more sense than looking at all the 500 stocks. So similarly, what we have done is, Honey, I Shrunk the movie, like that, we shrunk the entire model into one super feature. So SXI, or Sriya Expert Index, is now a sum total representation, dynamic, of all the important features. And it has a 3-step methodology called score, correlate, improve. So the first step is scoring, and it's not a simple score. It's a huge, it's about 8 to 10 machine learning models working in tandem. And it's called, there's a base, there's a composite, there's reinforcement learning, there is Gen AI. Everything comes together to form SXI, which is a score. So, okay, you got a score, big deal. How can I use it, right? I mean, is it worth it? I mean, what do I do with it? So the next step is to correlate it to an outcome, which is what we have done. Is the outcome, it could be like improvement in energy efficiency, reduction in machine downtime, increase in product yield. So it's basically linked to an outcome. And you see, so once the correlation is strong, positive or negative, this score actually now becomes a tunable, I use the word tunable, proxy to a non-tunable outcome. And so now you can have something like a joystick in your hands to tune it, so that you can get the outcome you want. And that's what we go by. Third step is improve. So once you have a correlated score, it's a proxy. So now you can say, okay, I want to improve my outcome by 20%. Okay, I want to improve my outcome by 20%. Whatever the outcome be. So you say, okay, my score last month was 10, and my energy efficiency was 70. Okay. So now, this month, I want the energy efficiency to be 80%. Fantastic. How do I do it? So we go back to the correlation curve. It's again a mathematical method, and we say in order for the energy efficiency to be 80%, the score has to go up, the index or the score has to go up from 10 to 14. Beautiful. Now you're looking at two variables. So it's multivariate to bivariate solution. Okay, so you've found the solution. I want a score of 14. Now tell me, Dr. Kilambi, how do I get from 10 to 14? What do I do to get those 4 points up? So then it'll go back and run the second layer of AI, use a score of 14, and generate a target decision tree, and gives with the actionable insights. I say do 1, 2, 3, 4. If you do these 4, you are going to get, for example, a score of 14. For example, if you try to do preventive maintenance, you'll say, please don't operate the temperatures beyond this. Don't do the RPM beyond 60. It'll give very specific paths. And if those are maintained, there's a certain lag time. You can't expect next minute, but it could be a day, a week or so. You will see the actual outcome improving to the desired number, 10% to 20%. Now, yes, can you go all the way to 100%? Yes, but we always say the baby has to crawl before the baby can run a marathon. So you got to go step by step. So you go 10, 20%, then reset. It's continuous learning. Then you have new data coming in, then 10, 20 more percent, one more reset. And so it's just compounded. So over a 3 to 4 months or a 12 months period, you will go towards 30, 40, 50, 60% improvements. But it's not going to happen overnight. But at least you will have a clear pathway towards 20, 40, and 60. This is a very unique technology because the focus is clearly on how to improve as opposed to how to predict. And we have seen a lot of testimonials. As one example we did for cement research. So again, so with this, I will stop. I'll have my my co-founder Steve, and he will generally go through the broad applications of the technology, and then he will hand over to Bala, who will talk specifically with respect to manufacturing for what you guys are here. Thank you very much for listening to me. Over to you, Steve.
All right, thank you, Srinivas, so much for that introduction and that comprehensive review of AI, machine learning, and especially our advanced AI squared solution. And a big shout out to any of the data scientists out there in the audience. Say thank you for that. If you want a deeper dive into AI, please reach out to us. I'm sure Srinivas would love to dust off his old professor hat and give you a more detailed dissertation on it. So now let's begin. I'm Steve Howell, the co-founder of our incredible company. My background is in engineering, and I'm an ex-CEO, investor, entrepreneur, hitting all different industries from laser eye surgery to global services, nuclear power, and so on. So it's perfectly fitting for me to be part of this crazy AI world. But on a more serious note, we began by asking ourselves, is AI squared a revolutionary? And in our answer, it became emphatic, yes. And to put it in perspective, I look at the evolution of a cell phone. It was extremely innovative joining voice and text, but not until Apple applied that app store did it really become a game changer. I mean, truly revolutionary. And we believe AI squared is at the cusp of a business improvement revolution. And what I mean by that is AI and machine learning models, they already exist. And generative AI is newer, absolutely, and extremely innovative. But it's that aggregation of our SXI indexing, which Srinivas was mentioning, coupled with our compounding super algorithms, and then providing a precise GPT roadmap that really becomes that catalyst. What we view is really creating that new type of leader. And we're kind of coining that as the CVO, that Chief Value Officer. So again, we're very impressed about where it goes. But so how do we apply this to industrial applications? Well, we focused on 3 business processes: forecast to sales, F2S, product to profits, you see it as P2P, and then order to cash, O2C. So, from this chart, you can see it's we sort of hit the entire business workflow, from obtaining sales to production to palletizing to delivery logistics and so on. I mean, it really encompasses all parts of a business or an operation. Now, we do also address HR, employee retention, and churn, but we'll save that for a different webinar. But today we'll speak to the product to profits that focuses on preventive maintenance, production yields, machinery equipment, and efficiencies, and so on. So that's kind of what we're going to be looking at today. And I think Srinivas kind of touched on earlier very briefly about the cement, but we applied AI squared to improving overall product quality of a new cement manufacturing process in January. Wow, that was only yesterday. we're February 1. So, I mean, the results that we saw from the work that we just started last month, 20% initial improvement. I think it was like 136.39% long-term improvement in the product quality materials. However, one of the greatest values is the specific roadmap. It's like that recipe AI Square creates to show how to obtain the overall improvement. So it pinpoints specific components that need to be addressed to achieve the overall goal. I mean, for example, large data sets were provided, but we found hold time, hold temperature, fuel content were determined by the algorithmic process to be the most critical factors to obtain that improvement goal. And again, and we get really specific. I mean, the optimal hold temp was determined, and the actionable insight, I mean, it was to be set at 500, I think 10.5 degrees Celsius. So the recommendation is that precise, down to like 1/10 of a degree. So needless to say, in this one example, our client extremely impressed, validated accuracy and results, and immediately entered into a 1-year contract to go towards full-scale production. So we got, again, a lot of opportunities and areas for improvement. Now, don't think that we only work in cement production. We have over 50 plus case studies. We have in 30 different industries, and we continue to see incredible results. AI Squared hasn't failed us yet, so we're up to any challenge that's out there. So again, let us know. We're always looking to do more trials and tests to kind of see where this goes. But this chart gives you a little bit of an idea of how powerful AI Squared really is, compared to what's out there as machine learning. Example, 99.9% accuracy for stock replenishments. That's a 27% improvement. 98% accuracy in wireless communications. 46% increase in improvement. So we also integrated AI Squared with reinforced learning, which is typically found in gaming, but we applied it to business cases for hotel bookings and financials, and so much more. So again, that provided, again, staggering results of close to 300% improvement, 95% accuracy. So I guess the point is, now imagine what this powerful tool could do for your industry, your applications, and your production process. So at this point, I'm going to now turn it over to Dr. Bala, who I'm sure everyone really wants to hear, because he's going to provide real-world experience and perspective of working with AI in industrial applications, and specifically pulp and paper. So Dr. Baller, you have the floor. I'm going to move this over. There you go.
Okay,
thank you very much, everyone.
Thank you, Steve, and thank you, Srinivas. I think there's a great opportunity we can discuss those in how it applies to process industries, chemical industries, and including pulp and paper. If you look at, we are going to look at, what is the status of pulp and paper adopting this technology right now, and then what are the challenges and opportunities, and then also look at, what specific areas have what issues or opportunity, and then we can look at, overall, how that looks like in terms of your facility, or what the opportunities for you can be. So before we head there, let's talk about preventive versus predictive. All of you may know that preventive maintenance is regularly scheduled maintenance, replace felts, wire, and do the lubrication and so forth, just to make sure that the equipment that we have in place are in a good order and also in good working condition, right? So predictive maintenance is where there are real opportunities. Historically, if you look at, on an average, the pulp and paper industry loses about 10 to 20% on unpredictable downtime, which leads to a significant loss in production. At the same time, they can't really schedule delivery to the customer because of all these issues. And over the past 5 years or so, it has gone a little bit better because of the tools and methods that we have incorporated into some of these processes. But in the last 5 years is where we really understand how to think about what data is available in terms of where the equipment is operating, and also employ tools such as vibration sensors, the algorithms that are built in to track the performance and so forth. That it was made available because of the enormous amount of data collection because of the IoT and the cloud computing and so forth. So there is significant data available today than it was historically, and because of that, we could achieve a lot more results than what it was before. So if I look at what has happened historically, you can see that the adopting this technology of AI, ML varies significantly. On an average, about 30 to 35% of all the chemical industries have adopted this technology, but to varying levels in terms of actually taking advantage of the digital transformation that we are talking about, employing these advanced tools. Generally, large amount of data does not always mean results, because when people started this, they started collecting all kind of data in different areas, and then they didn't know what to do with that data, right? So unless these data are given or taken out to drive decisions, this is just a pure data. It doesn't add much value. Plants may struggle to understand also the balance between the base data, how much data we need to collect, what data we need to collect, and the degree of automation we need to have, specifically in terms of how to run this more stable, and also what tools we need to employ. Do we need to have some software tools developed in addition to the automation? And how are we going to merge this effort with the existing automation? And these are all different for different mills and also varies by areas. So automated systems generally are capable of controlling material flow, monitoring production parameters, and so forth. But at the same time, if it is not done properly, and if there are tools that are working in specific areas, it may not be advantageous to us in some cases, because one set of automation or the loops can work against the next set of automation and can actually create more uncertainty and instability in that system. So it is important, if you take a group of equipment, it is important to understand the specific areas, what do we really need, and how complex this particular area is. If you take, for example, the digester area, there are continuous systems, there are batch systems. Whenever you say batch itself, it creates a little bit more variability than the continuous systems because of the nature of the batch systems, right? One batch always differs from the other one. But in a continuous system, to some extent, that variability is reduced. But at the same time, these systems are not, when they are not responding to external events that are external to that particular system. A good example can be the digester will always work in the same way without knowing that there is a change in the white liquor strength and the bath ratio and so forth. So it's going to spit out whatever it has been given out after cooking, right? So the variability that we caused inside right there, this can also be due to changes in chip quality or the moisture variation and so forth. This can propagate through the system. If you try to optimize, for example, in specific area like washing, just to optimize that system to get the highest solids you can get to the evaporators, that's objective of that washing. It can also leave significant amount of black liquor solids or the residual solids along with, which makes the bleaching cost much higher, right? So these are all the things that can work against each other unless you have a monitoring system that works, looks above all this in different areas. You certainly cannot achieve the best results that you can always achieve. Most of the issues in the operations that you see today in most of the manufacturing systems is because of the variability that is coming in or caused by how we operate, and the unreliability. I would say that about 10 to 15% of production time is lost because of unstable conditions or because of equipment status or product quality. Product quality is also affected. Good example is when a machine goes down, the next thing that happens is it takes 30 to 45 minutes, and whatever product we produce in that one is not up to the quality that you need. Next slide, Steve. So optimization of automation in specific areas, this is where the biggest opportunity is. There need to be a really good understanding of what degree of automation we need as a base and how much AI, ML tools we can build above that one. And also, how does it work in terms of increasing productivity, quality, lowering energy and so forth. And in specific cases, there have been instances where because of the automation and also the tools that were built in, we could reduce close to 50% of the operator touches. So it transferred from operator, constantly monitoring the system and changing conditions, and to just operator looking at how it is operating and making sure that the automated systems and the tools we put in are working to correct whatever issue we have. So AI has the capability to really help us in terms of advancing the operation and reducing the unplanned downtime, and also improving the productivity and quality in almost all cases. So that's where the real opportunity is. And when we, Steve, next slide, please. So if you look at it, this is, schematic of the different areas of the manufacturing in pulp and paper. I would say that, I have worked in food industry and also in pharmaceutical industries. Pharmaceutical is much tightly controlled because of the CGMP conditions and so forth. So the AI tools you can go above, but the opportunities may be somewhat less as compared to pulp and paper industry. And if you look at the fertilizers, there are real good opportunities also in employing these tools. Oil and gas, similar opportunities in terms of distillation and fractionation, how we control the system using AI technology. So on the pulp and paper side, if you look at the variability is introduced right there from the raw material and also going into the digester. There are tools today that we can monitor the moisture level, for example, the chip size and the distribution. We have really, really good tools today in terms of addressing those issues. What it does is, once you see the variability, the conditions in the digester can be adjusted accordingly to give a consistent product out of the digesters, for example. The degree of automation varies in different areas. For example, bleach plant is generally highly automated. You need different stages, and to control the best usage of chemicals, we do have quite a bit of automation in that system. In addition, we can put an AI tool to address the external things. For example, what is coming out of the brown stock washing, we can use that and then adjust the conditions of the bleach plant. Same goes for pulp mill to paper machine. One of the things that the industry is struggling, for example, is these loops are really tight. There is not much storage, for example, in some of the mills where they have 4 to 6 hours of storage of pulp, which if there is an issue in this segment, then the machine will run out of pulp, right? If you have a high degree of automation and also employing AI tools, that will help to still have that 4 to 6 hours of storage and perform much better than what it is without those tools. That's a really, really valuable advantage using this technology. Same goes for lime kiln. We have tools today to completely automate the lime kiln. And the operator would be monitor-centric, just to watch what is going on, as opposed to addressing the frequent issues that comes through the system, because there are models we can put in, just automatically corrects that system. The next thing is steam and power. That is, when we say steam and power, there is there are two things. One is the power is produced by burning black liquor. The additional power that is generated using the fossil fuels or natural gas or any combination of those, any of this system has trouble. For example, machine is down for 2 hours, then this gets really, really affected. Because the balance is tilted now between the steam and power production. And for somebody to lose about 5 to 10% of machine efficiency, that will be reflected also in inefficiency in this system and the rest of the system too, because pulp mill has to slow down in some cases, or whatever they need to do in terms of holding the digesters and so forth. So all these things are directly linked. So for a system to operate efficiently, we need to have some of these advanced tools built in. Same goes for paper machine operation itself. Today we have tools that can monitor how the machine operates and also periodically feed information on what issues we can expect, as we go forward. So those things did not exist in the past, like 10 years ago or something. Today we have significant tools where it said there is going to be a break. So those are all the things that we can monitor better. In some cases, when we employ some of these tools, we could increase the overall machine efficiency, OEE, also we call it, can be by 5 to 8%, depending upon where their baseline is. And in terms of finishing product, it's completely automated system, the finishing house, where there are unknowns historically where you lose about a couple of hours of their operating time. Because the loops are not working together, or there is some kind of issues which we could not identify, but the AI/ML tools today are helpful to identify those things too. So if you look at the whole system, there is varying levels of automation we can put in. That's where the efficiency of capital comes in. Historically, 10 years ago, if you look at somebody, I was doing a lot of capital work. If I look at capital, then always they think about dollars spent on the equipment. Today, the scenario is different, that we spend more on technology today as opposed to what it was. 20 to 30% of the total capital, or even sometimes beyond that, is spent on technology as opposed to equipment. So specific upgrades are critical in terms of having the base automation, and then build these tools to gain competitive advantage. So that, as I said, data correlations, ML, automated responses, and also use some specific algorithms built in. We have, most of these companies have, programmers. We have also, a whole bunch of programmers to build in the base logic in Python or any other tool to get ahead on this game and do better on the predictive maintenance and develop tools to improve the whole operation. So there is base operation. So degree of automation, as I told you, it varies based upon the area. And we do the AI Sriya tools, which helps to pull out the data from the operation. It can be DCS system, it can be Pi, or it can be Excel, where you can pull the data out and then analyze and then give the, as Srinivas said, correlation, and then helps to improve based upon the correlations established. So potential opportunities are variability reduction, as I mentioned above. In the previous discussion, AI/ML tools improves yield and usage, much higher energy efficiency. One of the things that is going on in manufacturing now is whenever there is a downtime, it also results in energy inefficiency because it takes longer to get back. Also, in some cases, there will be steam ejection from the system, emissions from the system, because we have overloaded the system. And also, just by addressing all these things, we could lower the cost. I think in some cases, the cost is as much as $10 to $15 per ton in some of these cases. And the technology tools, as I said, can also be used to substitute inventory. What that means is, if you have a much stable operation, you can lower the amount of inventory or the volume of inventory that you hold in warehouses, because your operation is steady and you can really deliver to customers on a much better controlled basis as opposed to what it was historically. So optimize raw material inventory. As I said, with the tools we have, we could today maintain the quality of pulp much better, because we have chip size distribution measurement today as opposed to what historically it was. And because of that, based upon the product quality and the varying product quality for different products, we could optimize the right size chips to get the right quality so that we don't end up in a lot of wastages. And predictable shipments, as I said earlier, to customers, more efficient supply chains and automated systems. And overall, it gives a different organization with different skills, not necessarily what it was before, so that people can effectively produce more in terms of the available time with all these tools that we have. So lastly, looking at all these different product segments, for bleached board market pulp, those are some of the ones that we can address easily for efficiency improvement, quality, chemical usage reduction, uptime and reliability. These tools can be employed like AI, automation, and reduce operator touches too. Sometimes operator touches also create more variability, because all of them don't react the same way. They try to overshoot in some cases in terms of corrections, and then they pull back. Those are all manual things. You just can do the best you can. You cannot control like a machinery can control. Medium liner board machines, same kind of quality. If you have a liner board machine or something, or a medium machine, you can completely automate the system from OCC plant to the machine and the warehouse with minimum operator touches. So tissue towel grades, the similar opportunities, and the specialty grades, we also have same opportunities in terms of cash cost, chemical usage, and uptime improvement. So if you look at lastly, I just want to give some statistics. If I look at the pulp and paper industry, it's about $1.5 trillion. It adds to the economy. The global pulp production is more than 400 million metric tons per year. And so if you implement some of these tools, you can see 5 to 10% improvement in throughput, 3 to 5% yield gain, and significant savings in chemicals, materials, and energy. According to McKinsey, it's a real $4 to $6 billion of opportunity. That's all I have. Thank you.
Well, thanks everybody. So if there are any questions, we'll take. Otherwise, we hope to see you soon in the next edition. Which again, thanks for joining today. Yeah.
Thank you, everyone.
Thank you. Thanks, everyone.
Have a great rest of the day. Cheers.